So let's start by doing some data structures. First, I'll build a linked list. It is like the simplest data structure, so um, it will be like a pretty simple main file. So let's start with the usual hello world. I think we also need to stdio. So yeah, everything works fine. So yeah, now let's create a data structure for the list. So yeah, I mean, as Copilot already guessed, we want to have like a structure for a node. And let's say that we want to have some data inside of this node. So it will be, let's say first it will be like a single int. We'll change it a bit later. We'll make it generic basically. So now what we need here is some way to um, think of the other nodes. So the way to do it is to have here a reference to another node. Probably it's a bit weird at first when you first see it, but uh, yeah, like probably how someone like for the first time would do it is like just do it like this. Um, let's see what happens if we try to compile the code. Um, yeah, it's a pretty weird error. So what you actually need to do is here have a reference to the structure. Basically, um, this would store only the address to something, like to this type of structure, so it doesn't need the structure to already exist, because when the compiler will look at the code, it will go through it, then it's not ready yet with building this structure when it gets here. So if you do this, it doesn't exist yet for the compiler. So you need to have like a reference, which means it's an like an address. So it will look like um, something like this. I'm just using some random address. So it would look like this, and then when you go into the RAM memory at this place, you will find basically this, the value of the next node. Or I mean, if you use null, it means that it's the end of the list. And yeah, as I said, here we now we store like an integer, but what we can actually do, let me maybe zoom in a bit more. What we can actually do here, instead of just using an int, we can have a void pointer to data. And now it's like the same concept. We have, instead of storing the exact value, we store a pointer to that value. Well, at least that's how it's intended. We have an address here, and if we go to that address in memory, we find the value that the user wants to store in this node. So basically, the user is now responsible for handling the uh, allocation and the freeing of the data. So some things that we might want to have for this linked list is like some basic functions. Let's say um, linked list new, maybe something like this. Actually, let me create like some let's say functions. Let's declare the types basically. Then I mean, I don't like that. I would like to have like an function like this. Basically, let's say that if the linked list managed to add a node successfully. We return like a status code, like 0 if it was fine, and I don't know, 1 to whatever if it wasn't fine. Then let's say that we want like a insert maybe, and we also like add will add at the end of the linked list basically, and insert will add at whatever index we provide. Um, then let's say, yeah, basically remove. It will also get the index, and then I guess what else can we have? Maybe like a free function, but I don't know. We'll see afterwards. Maybe like a print function. That might be. Wait, I mean this is a bit. Yeah, like of course, like a get function would make sense, but I was thinking that I don't know, we don't really need it. We need more like a linked list, maybe print, but yeah, it's interesting how to print the data. So let's leave it for the main function for the user to decide how to do it. So do you do it like this? Like you put a star. I don't remember what's the convention like for the variables. I know that you put like the star on the variable because yeah, I mean for example if you do like int a equals a b c whatever, if you do it like star here you might think that all of them are pointers, but actually only a is pointer. So if you do it correctly like this, it's I guess more obvious that only a is pointer and also b and maybe also c. So yeah, that's why you should put the star here, but I don't remember for functions. I mean, for functions could make sense also like this, but I mean, I don't know. So yeah, whatever. Okay, so I mean, obviously that's how you should do it. Um, I mean, I guess hopefully it makes sense. I guess I don't know. Maybe something that I will do here is if the list is null, just return null. I mean, you cannot do it. You cannot do this if the allocation failed. So might as well just do that. Now should be interesting to do the first operation of adding into the list. Linked list add, and yeah, maybe call it append. It's more like in Python and other languages which have I mean it's not a linked list, it's like an array, but it's like adding at the end. Star list and void void pointer data. So yeah, I mean it's a bit annoying that Copilot is already knowing almost everything, but basically the idea here would be we want to create a new node, and then we need to connect the list, basically the old list that we have, to this new node, but we need to add it at the end. That's because we have an append. So yeah, let's first create a new node. Let's call it new node. Why not? Oh yeah, if it didn't work, then we return some error. Okay, then we need to put the data. Then we need to set the next to be null. And yeah, basically now it's a bit more interesting. So actually I think that probably a better way to do it would be to have here a double pointer to the list and initially have it as null, so that we don't have to um, have like an empty node at the beginning. But I mean, should work fine with like an empty node at the start. It would be like the, I don't know, metadata node, let's call it. I mean, makes it a bit easier, I guess, if you do it like this. So then we need now, yeah, because it's a linked list, we cannot access the last node instantly. It's an of an operation. So we need to iterate the linked list now. So while the current next is not null, we can iterate. And yeah, I guess uh, so we look at this field, and if it has a value, like if it's got something that's not null, it means that it's an address. So we can move there and look again at the next field. So that's what happens here. We override the current value with the structure from the next place, and then we look again at next. And when next will be null, it means that current is the last element of the list. So then what we can do is say current next equals new node, and then return 0. And I mean, we can even just have a small example. So we create a new list. Then let's say, yeah, I mean, let's say it's gonna be a linked list with some numbers, I guess. Be okay, whatever. Let's see what it does. Okay, yeah. So one thing here is that maybe one mistake that someone can do is like, okay, let's put it like this first. So let's say, oh, let's add directly the value, but you cannot do that. I mean, you can, but okay, let's also include stdlib for malloc. I mean, you could, but um, this should have the type void pointer, and here it's just an integer. So yeah, I mean, you can then cast it to a void pointer, but see, like this would tell you that what's here should be like an address, and here we have a value, like we want a 1. So one way to do it is to put it inside a variable. Okay, now the variable a has the value 1, and if we put here like the address of a is like the place where the place in memory where we have a, it will be like, of course, on the stack because it's here defined in the body of the function, but nonetheless it will be like an address, not one. It will be like 0xff whatever, something like that. I'm not quite sure. And also there was a small typo here. We need semicolon after the struct declaration. And now it runs, but we don't show anything. So let's have more stuff. B2, B3. Okay, and let's add all of them. And yeah, now let's do same thing as we did here, but also, well, actually we can do it until the current is null, because we want to show all of them. So yeah, one thing that will happen if we do this, so this won't work because we have like the first node in our list is a null. Okay, so we get a segmentation fault. I mean, let's do it in bash because we get a segmentation fault. And yeah, now you might get stuck and be like, okay, what the hell? Why it's a segmentation fault? But when we do linked list new, so we create a node, we set the data to null and the next to null, whatever, we just make a node. And here when we add a new node, we create a new node again, like another new node. So it's the second node actually. It's not the first node that we put into the list. And then we add it at the end. So yeah, with this approach of doing like new here, we have another node at the beginning that we need to skip. And yeah, so now it works fine. Yeah, I mean, could also be worth it to have like a special case. I mean, yeah, sure. Let's try to do it like that. So here, let's change this to be a double pointer. Okay. So now what we are gonna do is instead of creating a new node when we create a new list, we won't create a new node. We'll set the node, the first node to be null, and that will indicate that the list is empty. So let's change this to a double pointer. Here we add a star. So we allocate not the structure itself, but the place on the in the memory where we are gonna store the address to the structure. Yeah, it gets really complicated when we have multiple pointers, but yeah, whatever. So we do the same check. If it's null, it didn't work, and if it worked, instead of setting the values on the data structure, we don't have that. You don't have that. So you do something like this equals null. So see how here, yeah, Copilot wanted to allocate the structure like the node. So yeah, basically you can figure it out that it's what we had before. So if you dereference it once, you get the same thing that we had before here. So yeah, it's I mean, we set it to null because we want to indicate that the list is empty. So this is the first node. Basically, the first node is null. So here we create the new node like before in append, and here we can check if list equals to null. Oh, yeah, and another thing here is since the list, like the first node can be, or the list can be empty. Basically, the first node will be null. We should send this as again as a double pointer because we might change the pointer to the structure. So here, I mean, we can do it in the beginning. If list equals to null, then that's a problem. The user didn't initialize the, just sent null here as a troll probably. So okay, now if the if we dereference this once, as we saw here in new, we get the pointer to the first node. If the first node is null, it means that the linked list is empty. So we can actually just change this to new node, and it worked. We return 0. Okay, so we just changed uh, the first node to the one that we just created, and yeah, since here is a double pointer, this change will take in effect because we change something like a value from where this pointer um, is pointing, basically. Okay, then if it's not null, then we can have a pointer to the first node, and then we just iterate like before, I think, probably. So now here we get a double pointer actually, which is interesting. So here we don't need to do anything else. Here we need to dereference this, and this should hopefully work. Oh my god. Oh, it was this thing here. Oh, it compiled that. That's a new one. And yeah, it actually works. So if, I mean, it's more complicated, I think, to do it like this, to have uh, multiple layer of pointers. But yeah, what it actually does is just it saves a bit of memory. So it's, I guess it's more of a thing for learning pointers rather than just something that's useful. So I don't even know if it's worth to do it. So yeah, for insert we'll also need double pointers because we can insert at 0 and that changes the first cell, first node. To be honest, I don't know for remove. I mean, let's just be safe and do it for remove also. So now insert insert. I mean, we can start by copy pasting stuff from above. Okay. I mean, we can do stuff like if, wait, let's make this unsigned, I guess. Why not, right? I mean, if it's unsigned, it we don't need to check if it's below 0. Let's make it simple. We only get indices like 0, 1, 2, 3. Okay, so yeah, here I mean, what if index is 0 is like a special case maybe because we insert in the start. So yeah, I mean, it's like the same thing as here, but I was just thinking, what if the list is empty and the index is not 0? Probably show an error, right? Okay, so if index is 0, then what we need to do is say new node, and this is interesting. Okay, we set the, so we want to insert the node at the start, right? And we might have something in list, or we don't, it doesn't really matter. So we take the node, we set its next pointer to be the first node, which is the list dereferenced, and then we overwrite the first node with new node. And basically this is how you insert at the start. You set this next value to the first node, and then we override the first node with the new node. And if you imagine it, yeah, you just put the new node as the first one. And let's see if we can copy paste some stuff. I mean, let's copy paste it and then we change it to whatever we need here. So here, I mean, let's make a for loop maybe. Let's try to use a for loop. For int I equals 0, I is less than index. Well, now it depends. Do you want index or index minus 1? I don't know, to be fair. I mean, index will be at least 1, so okay, so we have this thing, and let's say, yeah, basically if we cannot go to the next node, we return an error. The index was too large. Let's make it like another type of error, like -2 is index too large or whatever, index out of bounds. And then we have the usual current equals current dot next. Okay, fair enough. So now we have the current node that we want to change. So yeah, now it's interesting because there are, let's say, 3 nodes involved. So we might, no, we don't. It's fine. So this is not okay. So what we want to do is like break this connection between the current node and the next node, and in between the current node and the next node we want to insert the new node. Okay, so if we do something like current next equals new node, that's probably what you would do at first. This would set the next node to be the new node, but if we do this we lose the information about the next node, like we don't no longer have a pointer that gives us the old next node, right? So first we actually need to set the next of the new node, which is null from here. It's null, we don't care about it, but now we do. What? We care about the next node, which is, as I said, current dot next. Okay, that's the next node. So yeah, we need to set the next of the new node to the old next node, and after that we need to set the pointer that was pointing to the old next to this new node. That should be everything, I think. Yeah, and that should be everything. We also did this here. I didn't remember. Okay, so now we can try to have like, wait, what? Okay, I mean, let's reuse the variables. Let's try to insert 3 at the start, and then let's try to insert a 2 after it. Okay, let's try to insert a 2 after it. Well, it looks like, yeah, it was right. Here we should have index -1. That's, I think that's because here, well, well. I mean, let's also add here if list is null, which means that we don't have any node, we say index out of bounds, because it doesn't make sense to even try this for loop. But if we have at least one element, then we take the first one, and because, well, I mean, it's more intuitive to do it like this, I think, because here we access the first element, so we start the for loop already incremented by 1. Okay, so that's what this means. We start already at index 0 here if we do this, so we have to do like one less step of iteration. So if we run this again, see, we have 3 which we inserted at 0, and then 2 which we inserted at position 1 here. Okay, and now we have to do the delete. The delete function. Okay, this one. So yeah, as usual, we copy paste stuff. If the list is empty, -1. Now what's good is that we don't have to do this part or this part. Well, I mean, this part, yeah, we should do. Well, at least if index is 0, it's a special case. But here, because we delete from the list, we should also check this before index equals 0, because if the list is empty, then you can't delete anything. It doesn't make sense to delete something. So if index is 0, okay, what we need to do is to remove the first element. Okay, so to be honest, what I would expect is like you call remove, but probably you already have a reference to your data, so you can free it. Okay, so when I remove from here, let's say, how should we do it? We should have a temporary node that points to the node that we want to delete, which is the first one, and then we just move the list to the next element. Okay, and then we can free the temporary, but yeah, what I would also actually like to do is set the next of the temporary to null. Okay, And also maybe the data, why not? Like I would expect you to free everything, like free the data if you call delete. I mean, even if you free it afterwards, it's still fine. Just we clear everything just to be sure. I don't know. Okay, so if index is not 0, then we can do the same trick as we did here. Okay, we have a current. But see, this is interesting because we need, like, if we want to delete the current node, we need a node before it, right? So we also need like the previous, which is gonna be null at first. Okay, hopefully this will make more sense if we do previous equals current here. Okay, so previous will be the node one step behind current. Current will be the node that we want to delete, and current next will be the node after it. So yeah, I mean, prev next is current. Okay, so that's the link between them. So this thing right here would also work to put it after it, and just check if previous equals null. Okay, it's the same thing as index being 0. Or is it not? Yeah, what I'm thinking is that if we have here, if we start from 0, it makes more sense this time. Because if index is 1, we want to move one step more. I mean, you know, it makes sense to also start from 1 and not use previous and just delete current next. But I think it looks a bit, I don't know, cleaner if you use previous. So let's try it like that. Okay. So yeah, now basically we have previous and current, and we want to delete current. Okay. So how we do it is we set the next of the previous to current next, and pretty much that's that. I mean, now current is no longer in the list, so we set it to null everything, we free it, and we return 0. So yeah, I mean, if you set, so yeah, next, if you think about it, next is current. Okay, so the next of previous is current, and if we overwrite that value with current next, then current is no longer in the list. Okay, we just popped it out of the list. So I mean, let's see if we remove the first element, what happens. We should have 2, 1, whatever. Yeah, and now let's remove element 1 from the list. So we shouldn't have 1 there. Oh, I mean, let's recompile it. Yeah, and it works. And as I said, if we try to do something like 10, I don't know, um, and we take int result equals printf result, we should have -2 because it failed. But what's nice about it is that it doesn't crash the program. So, I mean, yeah, sure, fair enough, you should. Yeah, I mean, I don't have a language server for C. That's sad. So, yeah, I mean, what can I say? You should probably check the error, like the status code of each call and show some messages about it. But yeah, like how I would do it is probably if result. Yeah, I mean, it's cool that it understood. Okay, so yeah, something like this, or even maybe have this once in a function or in a macro or something, and then just reuse it for uh, for all the calls. So yeah, what you would see if we this is errors out of bounds. Yeah, maybe even adding like I know it's like some special variables like this, like file line number and so on, so you know where the bug was. But yeah, pretty much this is our linked list. So yeah, just basic operations for inserting, appending, and removing from the list.